Hello, welcome back to the channel. So let's continue our previous video on numerical integration and do one more question on finding a bound for the error in approximating different types of integrals using different types of rules that we already covered in the last videos. So in this question, we have to find a bound for the error in approximating this integral over here using the Simpson's rule with the given n equals 6 in this case. And again, we have been given all the information that we need to know in order to calculate the bound for the error. So you don't have to remember these formulas over here. And also, we have already covered this type of question in the previous video as well, a similar type of question, but that question was using midpoint rule. So I'll highly suggest you to first watch that video in order to get the full context of this question over here. So we'll follow the same approach that we followed in the last video. The first step is to calculate the value of L or M, and then after we calculate the value of L in this case, we will plug the value of L in this formula in order to calculate the bound for the error. And before calculating that, in order to find the value of capital L, we will have to find the maximum value of the absolute value of the fourth derivative of f of x. And in order to do that, we'll have to first calculate the fourth derivative of f of x. In this case, as you can clearly see as well, f of x is the function for which we are calculating the integral for. F of x is e to the power minus 2x plus 3x cube in this case. And if we'll calculate the derivative of this expression, calculating the first derivative, it would be simply minus 2 e to the power minus 2x plus 9x square. Second derivative would be 4 e to the power minus 2x plus 18x. Third derivative, minus 8 e to the power minus 2x plus 18, and then fourth derivative would simply be 16 e to the power minus 2x plus 0 in this case, right? So the fourth derivative would simply be 16 e to the power minus 2x in this case, right? So we started from f of x and then calculated the value of the fourth derivative of f of x because we needed this value in order to solve for this inequality over here, right? So now since we have this fourth derivative of f of x, let's simplify this down. So if we simplify this expression over here, we can simply write this expression as 16 upon e to the power 2x, right? So now we know that the exponential function is always positive. So taking the absolute value of this expression over here wouldn't change anything, right? Because we know that exponential function is always positive. So taking the absolute value would not change anything, right? Because taking the mod of or the absolute value of 16 upon e to the power 2x is basically the same, right? 16 upon e to the power 2x. Since both of these values in the numerator and the denominator are positive. So we know that now we got the fourth derivative of f of x, and we know that the absolute value of the fourth derivative of f of x would also be this expression over here. And now we want to calculate the maximum value of this fourth derivative of f of x to calculate the value of L for all the values which lie in between this interval over here, right? So we know that x is varying from 0 to 1. And if x is varying, we know that if x is varying from 0 to 1, we can clearly see that this expression has the exponential function in the denominator, right? And we know that exponential is an increasing function. So if we have an exponential function in the denominator, this makes the whole expression as a decreasing function, right? Because we have the exponential function in the denominator, and we know that as x would increase, the exponential function also increases, right? But since in this expression, the exponential function is in the denominator, so as x will increase, this expression will decrease, right? So I hope that makes sense. Feel free to comment down if you still have any doubts regarding this portion. So we know that this is a strictly decreasing function, right? And since we know that this expression is strictly decreasing, we know that the maximum value of this expression will occur when x is very small, right? And based on this interval, x is the smallest at x equals 0, right? So for this expression, if we want to calculate the maximum value of this expression over here, it would simply be when x is equal to 0, because this is a strictly decreasing function, and as x would increase from 0 to 1, this expression will decrease. So the maximum value of the fourth derivative of f of x would be when x is equal to 0, and that would be, so when x is equal to 0, we'll get the value of L as well. So when x is equal to 0, the fourth derivative of x is 16 upon e to the power 0, which is basically 16 in this case, right? And this is also equal to the value of L in this case, right? So now we got the value of L, and the only step which is remaining is to calculate the value of the error bound by plugging all the values that we know in this formula over here. So the formula is this, and we can write the formula over here as well. The formula is L upon 180 times b minus a times delta x to the power 4, right? So delta x to the power 4. And now we know that since our x was varying from 0 to 1, we know that our a is equal to 0, our b is equal to 1, and in order to calculate the delta x, we know that delta x is basically b minus a over n. Our n is given in the question, our n is 6. So if we try to calculate the value of delta x, it would simply be b minus a 1 minus 0 upon 6, delta x would be 1 by 6. So now if you want to calculate the error bound using this formula, which we also denote as En, it would simply be L, we already calculated it's 16. So it would be 16 upon 180 times b minus a is 1 times delta x is 1 by 6, and this to the power 4. So if you'll calculate this expression over here, you'll get the final answer and also the answer to the bound for the error in approximating this integral using the Simpson's rule. So that's it for this video. Again, we used the same concepts that we covered in the last video in order to solve this question over here. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.